Right. Hi everyone, welcome back to the channel. So today we have another Codeforces round and it is an educational Codeforces round today. So yeah, let's see how this one goes. And my main aim here would be to obviously save candidate master again. But just in case if I perform really very well, then I might, reach master as well. But obviously like to reach master, I would need a plus 90 here and that is really difficult. So it would be something like if I perform exceptionally well, then maybe I get a plus 90 here. But apart from that, the main aim here would be to save candidate master. And yeah, let me just see if everything's fine. Okay. Cool. Okay, here we go. Problem A. Okay. Makes and sells pizzas of three sizes. Small size consists of 6 slices, medium one consists of 8, large one consists of 10 slices. Baking them takes 15, 20 and 25 minutes. Okay, 6 slices, 15 minutes. 8 slices, 20 minutes. Okay, 10 slices, 25. Okay, cool. His birthday is today and n of his friends will come, so he decided to make an order from his favorite pizzeria. Okay. Wants to order so much pizza that each of his friends get at least one slice of pizza. Okay. Your task is to determine the minimum number of minutes that is needed to make pizzas containing at least n slices in total. For example, if 12 friends come to Petya's birthday, he has to order at least 12 slices. Okay. And okay. He can order 2 small pizzas containing 12 slices, and yeah, that would take in order in overall 30 minutes. Okay. Right. So if I can express it as as sum of some multiples of 6, 8 and 10, then I'm not wasting any time here. That is the thing. Yeah. 6, 8 and 10. If it is even, then I'm not wasting any time. So that's just like n by 2 into 5. Right, yeah. Yeah, then it should be n by 2 into 5 because I'm not wasting any time. But if it is odd, then I can just consider the first even number, right? Yeah. So what I have here is so if n modulo 2 is not equal to 0, then I do n plus plus n by 2 into 5. Thirty, 40, 750, 15. Okay, we are getting 15 here. How come? Okay, this is when n is greater than 6, right? So if n is greater than equal to 6, else you just see out 15, right? So this should be fine, I think. Yeah, let's submit this. Okay, cool. So we're done with the first problem here. Moving on to the second one. You have an axis aligned rectangle room with width W and height H. So the lower left corner is 0.00 and the upper left and the upper right corner is WH. Okay, there is a rectangular table standing in this room. The sides of the tables are parallel to the walls. The lower left corner is x1, y1 and the upper right corner is x2, y2. Okay. You want to place another rectangular table in this room with width W and height H. The problem is that sometimes there is not enough space to place the second table without intersecting with the first one. You can't rotate any of the tables, but you can move the first table inside the room. Okay. So if I can move the first table inside the room, okay, what are they actually asking here? Okay, minimum distance that we have to move the first table so that the second one fits, right? Yeah. Okay. So if I just have to fit the second one, I mean, it is always better to fix it towards one corner, right? Why would you fix it somewhere in the middle? Just fix it towards any corner, right? So that should do. Okay. So when we're talking about the second table, it is always better to fix it towards a corner. So I just have okay, first line contains W and H, this is fine. Second line contains x1, y1, x2, y2, right? And third line contains right. So let's just define, the corners. The first point is what? The first point is 0, 0 basically, right? Yeah. Okay. So if we want to fix it for 0, 0, okay, just a minute. This is W, this is H, okay. So the 4 points that I have are 0, 0, 0, W. Okay. No, that should be W, 0. Right, yeah. This should be W, 0. The upper one should be 0, H, and that one should be H, W. P1 equals to 0, 0. Okay. This one will be W, H, right? Okay. So if I fix the lowermost corner to 0, 0 and the uppermost to W, H, right? So now your x coordinate has to be shifted how much? Your x coordinate has to be shifted. Okay. Let's keep it infinity, and we'll have this. So I'm just telling the points here, right? Yeah. And that is the point of the leftmost corner point, right? So here, first of all, I have 0, 0, w, h, and let's just initialize them as global. Yeah, so this is my point here, and the next point will be w minus w and 0, right? So first point here again will be 0, and this will be h minus h. This will be w minus okay. Okay, so I have the first width. So this is x2 minus x1, h1 equals to y2 minus y1, w2 equals to w, h2 equals to. Now clearly, if w1 plus w2 is greater than bigger w, and or h1 plus h2 is greater than h, then you return infinity, because this is not possible, right? And if it is possible, then I just sort of find the intersection. Yeah. Okay, so I have to find the intersection and I have to move it that much. Okay, either I can move it by the width or I can move it by the height. Okay. So first of all, I'll try to move it by the width. So if w1 plus w2 is less than equal to w, right? So this is the segment 1, and this is like a and a plus w. I mean, why would you move it diagonally? It is always better to move it either horizontally or vertically. So sec2 here will be x1 and x2, right? Yeah. So if minimum of x2 comma, sorry, sec2 dot ss comma sec1 dot ss is less than max of sec2.ff. So if this is the case, then they are not intersecting, right? So in this case, I can just return 0. Else return. So I'll just have to shift it, right? Yeah. So this is fine, and similarly, so first of all, I'm checking if it is intersecting or not. So segment 1 is A and A plus W. Segment 2 is x1 and x2. So x2 is greater than x1, right? Yeah. Similarly, if h1 plus h2 is less than equal to h, then I'll have my two segments. So this will be B, and okay, and this will be B plus H, right? So again, if they're not intersecting, then answer is 0. Okay. So I have 1, -1, 2, 2, 0. Okay, so I also need to have it. Okay, let me just do set precision. Don't I have this in my template? So I don't have set precision here, but I don't think it should matter. Yeah, this shouldn't matter. So this is fine. Okay, wrong answer on test 3. Okay. So why am I getting a wrong answer here? So width 1 is this, width 2 is this. Right, I hope I'm taking the input fine. So I have x1, x2. So why would I not want to pin it to any one of the corners? I think that should be fine. Maybe I'm passing the wrong coordinates. So I have 0, 0, and then I have w minus w and 0, and similarly I have 0 and h minus h. x2 minus x1, y2 minus y1. This is height, this is the second height. So if w1 plus w2 is less than equal to w, then I can do this, right? Yeah. Okay, let's have a table of size 2 cross 2, and I have 0, 0, 1, 1, right, and then I have 1, 1. Do I have to move anything here? I don't think so. Yeah. Similarly, let's have 3, 3. And what about 2, 3? Right. If I have it here, let's say, and then I have 2, 3. Yeah, so what is the issue here? x1, y1, x2, y2, this is fine. I don't know what is the issue here. This should be fine. Let me read the question once again. Is in point and the upper point is okay. Where exactly is it going wrong? I'm not able to understand. Let's have 1 cross 3 and 2 cross 3. So I have 0, 0, and I have 1 comma 3. Okay, so if I place it on 0 0, oh, so it is not about moving the second table. We cannot move the second table. We only have to move the first table. Right, yeah. Okay, so we only have to move the second table, right? Yeah. Sorry, we only have to move the first table. So how will I check which table, which table am I moving? Okay. You have to move in the other direction. Right, yeah. So I cannot do this. Let me think about this. equals to 0, then my answer will be a plus w minus x1. Else it will be so if b equals to 0, then I have answered 2 equals to b plus h minus y1 by 2 minus b. Yeah, so this should be 2 actually, like this shouldn't have been 1. That is the thing. Because we're only moving the first table, we're not moving the second table. So 1 minus 1, 2, 2, 0. I think this should be fine now. Let's submit this. Okay, cool. So yeah, the main issue here was that I was moving both the tables. Only the first table had to be moved. So no issues, but yeah. It took up a lot of time. Okay, maybe C and D are easier. Okay, let me try C then. So apparently people are solving C faster than D, and I mean C faster than B. So let's look at C. Are playing a game on a matrix consisting of 2 rows and m columns. The cell in the ith row okay, initially both Alice and Bob are standing in cell 1, 1. Move right, okay. Move down. First Alice makes all her moves until she reaches 2m. She collects the coins on all cells she visits. When Alice finishes, Bob starts his journey. He also performs the moves to reach 2m and collect the coins that he visited, but Alice didn't. The score of the game is the total number of coins Bob collects. Alice wants to minimize the score, but Bob wants to maximize the score. What will be the score of the game if both players play optimally? Okay, so if I pick up any path, then Alice can already cover that path overall. But the thing here is that Alice has already taken her chance, so it is Bob's chance now, so he can decide how the game looks, right? So Alice will try to minimize this whole thing. Okay, pretty cool. So I think here Alice should only remove the maximum one. Like first Alice can remove the maximum one and then Bob can decide whatever he wants to do. Right, yeah, I think that should be fine. But here the case is that there can be more than one maximums. So Alice has to make her move first of all. So the thing here is that if Alice chooses any path, we can choose the other paths available, and we'll choose the maximum in that. So if we are choosing the maximum, then Alice should just remove the maximum from this overall grid, right? Yeah. Is this problem that easy? So Alice wants to minimize, Bob wants to maximize. And Alice has taken her chance already. So ideally Alice should be choosing the path that gives her the maximum answer. Right, and if there are multiple answers like that, then which one should she choose? Yeah, I think she should only remove the maximum one. You cannot attain the maximum at all. So this is fine. So this just means that we are going towards the right. Equals to what? Equals to 1. So this means we're going down, right? Yeah. Right. So now what I need to do is I just need to do this. ARR at I comma j equals to 0, and then if dp at I comma j dot ss equals to 1, then I do I plus plus else j plus plus, right? And then I just need to do this whole thing again. Now what happened? dp of I comma m. Okay. Okay, why am I getting 0 here? So I have 0, 0, 1, 0. Oh, I think I've taken the wrong input here. This should have been n, right? So I'm getting 8, 8, and but I should be getting 7, right? So let's just consider the very first case only. So I have 0, 0, 0, 1. Then I have 0, 2. Oh, okay. So Alice went on this path instead of going on the maximum one. Right. So there is an issue here. So clearly when I'm standing here, I need to check from where I can get my answer as maximum, right? Yeah. So if I go here, yeah, then this will be my maximum answer. But if I go here, okay, so let me think again. So which path should you choose? That is the whole thing, right? Yeah. So if I'm standing on 1, 3, and then I should either go to 5 or I should either go to 7, right? Yeah. So the thing here is that it is all about 2 cross m. I think that is the whole point. And if I'm in any row, I can, yeah, I think in every row I should just remove the maximum one, right? Yeah. Okay. Okay, let me think about it. So the thing here is that once I move down, once I come down, I cannot go up again, right? Yeah. Okay. So I don't need all this. Once I come down, I cannot move up again. That is the whole idea, right? Yeah. Yeah, so if I say that I'm doing it for this much, oh right, we cannot go up again, right? Oh, okay. Oh, okay, right. Ten. How am I getting 10 now? Oh, okay. Okay, this is 8, this is 8 again, and this is 4, right? Yeah. So I have 1 4 11 and 9 6. Okay. So I could have chosen this 12, right? Yeah. This should have been M, right? Now this should be fine. But why am I getting 8 here? I should be getting 7, right? So I have 6 plus 4. And what are the remaining elements? Oh, it does not have to be the remaining ones, right? Yeah. So U again cannot come up and down, right? Yeah. Oh, okay. You can either take up the prefix or you can take up the suffix, right? Yeah. So if I take up the prefix, then right. So this should be I is greater than 0, and I have prefix 205. Okay, I is greater than 0. So this prefix 2 at I minus 1, sorry. And I is less than M. Oh, this has to be max, right? Not. Okay, cool. So it actually took up a lot of time, but yeah, no issues. We still have a lot of time. Okay, let's look at the fourth problem then. All right, yeah. Say no to palindromes. If it does not contain a substring of length at least 2, which is a palindrome. Let's define cost of a string as the minimum number of operations so that the string becomes beautiful. If in one operation it is allowed to change any character of the string to any one of the first 3 letters of the Latin alphabet. Okay. You're given a string s of length and each character of string is one of the first 3 letters. Oh, okay. You have to answer m queries, calculate the cost of substring. If it does not contain a substring of length at least 2. Okay. Substring is BAA. Okay, so we cannot have 2 adjacent characters as same as well, right? Yeah. And similarly, we cannot have something like BAB because that would make it 3, right? Yeah. So the first condition that we want is no 2 adjacent characters should be same. That is the very first condition. And apart from that, if we talk about any 3 characters, then it should be ABC only. It cannot be. Yeah, so if we talk about any characters, it should be ABC. Right. It can be BAC as well, BACB. But it has to be periodic. Yeah. So I can calculate the length for every case here. Like if I want to start from A, or if I want to start from B, or if I want to start from C. But it is also about the substring here, right? So this would be order of n, right? Okay. So there are cases here, like I have 6 cases here, like I can do ABC, or I can do others as well, right? Yeah. So I have to consider 6 cases here. I have ABC, then I have ACB, then I have BAC, and then I have BCA. Similarly, I have CAB, and then I have CBA. Right, so these are the strings that I need to consider. Right, so I have to start with one of them, right? Yeah. So if s at I equals to perm at j comma 0, right? So the string has to be periodic. This is one of the things, right? Yeah. Okay, so for all these 6 strings, I can just find out these answers, right? Yeah. Yeah, this should be fine. Then we can just find out the answers for all the 6 cases, and then we should be done. Okay, this T has to be 1. So I have ABCAB, then I have ACBAC. Yeah, this is fine. Answer at j comma I equals to ref plus s at I is not equal to vals at I. Right. So then I just have to find out the answers, right? And val1 equals to answer at I comma answer at one two zero one. Okay, let's submit this. Let me just check those 6 strings if they're fine. ABC, ACB, BAC, BCA, CAB, and CBA. Yeah, this is fine. Okay, cool. So now we can look at problem E then. Yeah, let's look at problem E now. 233 submissions. You're given n segments on a number line numbered from 1 to n. The ith segment covers all points, integer points from Li to Ri and has a value Wi. Okay. You're asked to select a subset of these segments. Once the subset is selected, it's possible to travel between the two integer points if there exists a selected segment that covers both of them. Oh, okay. A selected subset is good if it is possible to reach point M starting from point 1 an arbitrary number of moves. The cost of the subset is the difference maximum and minimum values. Okay. We're given n segments on a number line numbered from 1 to n. The ith segment covers all integer points from Li to Ri and has a value Wi. You're asked to select a subset of these segments. Once the subset is selected, it's possible to travel between any integer points if there exists a segment that covers both of them. Oh, okay. Subset is good if it is possible to reach point M starting from point 1 in arbitrary number of moves. Okay. The cost of the subset is the difference between the maximum and minimum values of segments in it. Alright. So they don't have an explanation here. Okay. So the segments are 1, 5. So we have 1, 5. And the value is 5, right? Then we have 3, 4, 10. It's possible to travel between any two integer points if there exists a selected segment that covers both of them. Oh, okay, so you can move from segment to segment, right? So you want to select a certain subset of segments such that you go from 1 to m without any stoppage. Okay. There exists at least one good subset. Okay. Right, let me think about this. Okay, so what I can do here is that if I just sort the segments according to their values, yeah, let me just draw it. Okay, so if I just sort the segments according to their values, let's say these are the segments, and I say that I am starting from this segment. I mean, that is, I am just skipping all these segments. So what I would want to do is I would want to pick up as many, as less segments towards the right so that the difference is minimum. Right. So this can be done via a two-pointer. Like if I start from this point and I put all these, let's say, segments, and then yeah, so if I would be removing this segment, I can just simply, what I can do is I can just simply remove this. So I'll have to do a segment tree with lazy propagation here that supports range minimum. Okay, what is the memory limit here? Memory is 256 MB. I think that should be fine. So here is what I have. I have int n and m. Right, so this is fine. Let's just quickly test. So I'll have to do a two-pointer here, right? Yeah. Okay. Okay, so I'll have to also look at the segment tree, right? Right, so I have build tree first of all. Okay, let's make it 1e5 plus 6. 1e6 plus 5. Right. Right, this is fine then. Okay, I don't have to pass the lazy here. Okay, so this is working fine. Yeah. So first of all, if j is less than I, then I have to include this, right? Yeah. So, and I have to support minimum here. So minimum is fine. Yeah. LL value. Right, so I think it is the exact same thing what I'm looking for. Yeah, this should be fine. ARR tree lazy. Max and -1. And then I have a segment at j dot ff comma segment at j dot ss. Right, so I have ARR tree lazy start end index. Okay, I also have value here, so I can pass in 1. So while j is less than n, so first of all I'll have to query. ARR tree okay. But there has to be a point where it is overlapping for 2 segments, right? Yeah. So if x equals to 0, like this is trivial, then I have to do this. Right, this is one thing. Now clearly we can do this again. So if x equals to 0, then I cannot update my answer. j dot. So there has to be some modification again here. We'll have to figure it out. Oh, this should have been V, right? Query lazy tree. Okay, we don't need ARR in query, right? Okay, I forgot to do I++ here. Okay, so we're not concerned about M here. 1e6, we are concerned about M. Okay, so we have 3 here. Ten, 12, 1, 5. J dot W minus. So I think I'm missing out on one condition here. It is that they have to be overlapping. So 10, 12, 1, 5. 10, 12, okay. So how am I getting 5 here? Okay, for 1 comma 3 it is saying 0. So 1 comma 5 is covered, 4 comma 10 is covered, then 11 comma 12. 1 comma 3 it is saying 0. 0, 1, 2, 1, 2, 3. Okay. Okay, so I'm getting 1 here, but I shouldn't be getting 1. 4 to 10 is fine, but I also need 11 to 12. It has to be done this way, but there is one more thing that needs to be taken care of. What about this one? So I have to take care that I'm not considering segments that are just, like this. Yeah, so what I can do is I can subtract 1 and add 1 from that. A plus 1 and B minus 1. So if A is greater than B, then I do, if B at I dot A is greater than I dot B, here I just simply do V at I dot A equals to 0 at I dot B equals to 0. So now what I want is I want from 2 to m, right? Yeah, 2 to m minus 1. So if m equals to 2, then we are done, right? Okay. So first I have 11 comma 11. The value is 3, right? 3 comma 4. So how exactly is 3 comma 4 helping us? That is the point here. Maybe I have to consider it in terms of decimal points. Yeah, so we gone from 0.5 to m minus 0.5. Yeah, it has to connect to 11.5. So the number of points in between these points are m minus 1 actually. This can remain a and this can become b minus 1. Right. Now I am looking for the case here 1 comma m minus 1. So I am getting 3 here, which is fine. Okay, cool. Okay, cool. Yes. So the time limit is 3 seconds. I think it should be fine. Yeah. So the good thing here was that in my template, the code was exactly what I wanted it to do. So I hadn't had to, make a lot of changes here. So this is cool now. So if I talk about the logic, I can maybe explain that in the post-contest discussion. But there are like a lot of things that I've used in this problem. I've used segment trees, I've used lazy propagation, and I've also used 2 pointers, and then I've also sorted the whole array. So I was getting minus 41, but I think now I should be getting a positive delta if all the solutions actually are correct.